Okay, this is John Allison from Arkansas A&M. I'm here to work number 6 on the AP Calculus BC exam. Remember, I've solved these cold. I've not looked at the problem at all, and so I'm going in. It's been a couple years since I taught BC Calculus, so if I mess up, please forgive me. But it's possible I messed up on any of these videos because I'm human and I'm looking at them cold, trying to simulate as close as I can what students face when they take the exam. Part of the reason I do this is to show the kids and other teachers that it's okay to mess up. It's okay to not be perfect, and you can still score well on the exam. So let's get started. Switch to the document camera. Looks like we're zoomed in. So I'm going to go over here. I'm going to look at the problem now for the first time. Here we go. We just did number 5 a second ago. All right, we have a Taylor series for a function about x equals 4. Says it converges to f of x on its interval of convergence. Using a ratio test to find the interval of convergence of the Taylor series for f about x equals 4. Then justify your answer. Okay, I need the general term, which it looks like this is sum from n equals 1. I'm going to show you this in case you can't remember. I don't post the problems on here because College Board doesn't like it when we do that. They want us to protect their copyright. With 3 to the n. This is the sum. Converges to f of x on its interval of convergence. And so we're going to do the ratio test on the interval of convergence. So I'm going to do absolute value of the n plus first term. It's going to be x minus 4 to the n plus 2 over n plus, n plus 2 times 3. Sorry, that's 3. Can't read my own writing. To the n plus 1, all divided by, still absolute values, x minus 4 comes to the n plus 1 over n plus 1 times 3 to the n, and we're taking the limit. N goes to infinity. We're going to equal the limit. Because n goes to infinity. All of, let's do that again. X minus 4 to the n plus 2 times n plus 1 times 3 to the n over x minus 4 to the n plus 1 times n plus 2 times 3 to the n plus 1. It's going to equal the limit as n goes to infinity of absolute value x minus 4 times n plus 1 over n plus 2 times 1 over 3. This limit goes to 1, so that equals the limit of 1/3. Let's do it. Get that inside. Limit as n goes to infinity of x minus 4 over 3. And we need that to be less than 1. We need that to be less than 1. If absolute value x minus 4 over 3 less than 1, Don't need a limit, do we, for the ratio test? Yeah, we do, but we can drop the limit because there's no more ends. How about? Yes, we do. All right. So that means that this is going to be the absolute value of x minus 4 less than 3. Sorry, I told you it's been a while since I did this. All right, so that means negative 3 less than x minus 4 less than 3. That means 1 less than x less than 7. So the ratio of convergence, the radius of convergence is going to be 3. And now we need to test to see if that limit is true when at the endpoint. So if we look at the limit as n goes to infinity of 1 minus 4 over 3 absolute value, that equals 1. Negative 1. Absolute value is negative 1, it's 1. It means it does not converge at 1. So the limit as n goes to infinity of no, let's look at the original term, sorry. The original term. Let's look at the limit. N goes to infinity of plug in 1. I get 1 minus 4 or negative 3 to the n plus 1 over n plus 1 times 3 then. Here we go. Been a while. Like I said, I apologize. Which equals the limit as n goes to infinity of, this is going to be negative 1 to the n plus 1 times 3 to the n plus 1 over n plus 1 times 3 to the n. So that is limit as n goes to infinity, negative 1 to the n plus 1. This is going to be 3 over n plus 1, which does equal 0. Therefore, converges as n at 1. And then we're going to look for x equals 7. The limit n goes to infinity. Three to the n plus 1 over n plus 1 times 3 to the n equals the limit as n goes to infinity of 3 over n plus 1, which does equal 0. So that means the radius of convergence is 1, 7 inclusive. Okay, I hope I did the ratio test right. That was part A. B. Let's find the first 3 non-zero terms and the general term of the Taylor series for f prime. Okay, so we need the first 3 non-zero terms for the Taylor series. So f prime is going to equal f prime of x approximately equal to c of x is going to be the derivative of this, which will be n plus 1 times x minus 4 to the n over n plus 1 times 3 to the n plus 3, yeah, 32. Well, they give us the first few times. We can just take that directly. Forget that. They gave us the first term. So we'll go 2 times x minus 4 over 3 plus, this is going to be 3 times x minus 4 over 3 times 3 squared. So this is going to be x minus 4 squared over 3 squared plus, and this is going to be, the 4 is going to cancel out, so x minus 4 over 3 cubed. And since this is the first term, plus dot dot, and the general term. I'm going to put the general term here. Looks like this is term 1, 2, 3. So it's going to be x minus 4 over 3 to the n. That looks approximately right. Do the derivative term by term. They want the first 3 non-zero terms. These are non-zero terms. Okay. So there's a series for f prime described by part B is a geometric series for all x in the interval of the convergence of the Taylor series for f prime. Show that x minus 4 over 7 minus x equals f prime. How about if we do? X minus 4 over 7 minus x. Geometric series. All x in the interval. Okay, that's true. So that means, I got you. So this is a geometric series, which means that t of x equals the sum of x minus 4 over 3 to the n from n equals 1 to infinity. And there's no coefficient there. In the interval of convergence, this is going to be 0 or between 0 and 1, or between -1 and 1, not including -1. Yes, it will include. This is okay, this is the derivative. It's not going to include the endpoint in the interval of convergence of the Taylor series. X equals 7. Continue. I'm not sure where. Let's see. Then make it. All right. So this would mean that x minus 4 to the n. So this is going to equal 1 over 1 minus x minus 4 over 3. So I'm going to multiply, and it's going to be 1 over 3 minus x minus 4 over 3 equals that raised to the nth power, or that gives me 3 over Interesting. This is not giving me what I thought it would. F prime. Oh, never mind. Idiot. First term's got to be 1 in geometric series. This is wrong. So that means that t of x is going to equal x minus 4 over 3 times 1 plus x minus 4 over 3 plus dot dot dot. Now we're going to get there. X minus 4 over 3 times 1 over 1 minus x minus 4 over 3. That's going to equal x minus 4 over 3 times 1 over 3 minus x minus 4 over 3. And that's going to equal x minus 4 over 3 times 3 over, this is going to be 3 minus x plus 4, so it's going to be 7 minus x. These are going to cancel, and that's going to leave me with x minus 4 over 7 minus x, and that will prove that. All right. That was a little bit of a struggle for me. Like I said, it's been a couple of years since I taught BC, so how to practice a little bit. I'll make sure y'all can still see this. And we'll go to work on what's part C? How do I get part B there? First 3 terms, that would be, so this was C. Okay, there we go. Now we're going to go to part D. It's known the rate of convergence of the Taylor series for f about x equals 4 is the same as the radius of the convergence of the Taylor series for f prime about x equals 4. Does the Taylor series for f prime described in part B converge at f prime of x at x equals 8? Give a reason for your answer. Okay, so now I'm curious because this obviously does not converge at the endpoint, and I got that it did. So curious about that. Well, look. If I plug in 1, I get negative 3 to the n plus 1. That's over n plus 1. That's an alternating series. I plug in 1. If I plug in 1 there, I get negative 3 to the n plus 1. I plug negative 3, negative 1, 3 to the n plus 1, negative 1 times 3, so n plus 1. That limit equals 0. But it doesn't converge. That's what it was. I was trying to apply the conditions of the ratio test. All right. So at 1, this is an alternating harmonic series. And so it does converge at x equals 7. And how would this one converge at x equals 7 when it doesn't? This, no, it's not alternating when x equals 7. It doesn't converge at 7. At 1, negative 1, 3 over n plus 1. So this should converge at 1, but it does not converge at 7. alternating harmonic. Was similar to. And similar to harmonic. So this is going to be principally not. Let's put 1 less than or equal to x less than 7. Okay, this one doesn't converge at 7. That makes sense. Okay. So now it's known that the rate of convergence of the Taylor series for f about x equals 4 is the same. So does the Taylor series for f prime converge at x equals 8? No. Because 8 is outside the interval of convergence. Of f prime, since we know the interval of convergence is the same. 1 less than or equal to x less than 7 for f and f prime. Okay, that should be it for number 6. All right. Thanks for watching. Sorry that was a struggle. Like I said, it's been a little while since I taught BC, so the ratio test and all that get me confused a little bit. It's been a while since I worked on it. So anyway, hope you see it's okay to struggle and we can still get to the test and score well. Thanks for watching.